So for today's lesson, we are going to look at graphing a quadratic equation when it's in standard form and in factored form. We've already learned how to graph a quadratic equation in vertex form using the step method. So today we're going to look at that. These are the answers to some of the questions from the homework. Let's have a look at those. All right. Now, like I said, when we were graphing using graphing equation in vertex form, we would use the step method. That's the most common way of doing things, or the easiest way of doing things. Now we're going to look at graphing when it's not in vertex form, we're going to factored form or standard form. So when the equations is in standard form and you have to graph it, my first suggestion is that you put it into factored form, and that way you can identify some key pieces of information. So to put this into factored form, two numbers are multiplied to get -8, but add to get +2. So y is going to be equal to x plus 4, x subtract 2. And from here we can start identifying key points that helps us to graph this equation. So our y-intercept is going to be our constant. So this is our y-intercept. That's going to be -8. And then our x-intercepts are going to come from here. So this is going to be x plus 4 equals 0. X equals -4. Oops. This is going to be x subtract 2 equals 0. X equals 2. So our x-intercepts are going to be -4 and 2. Now we can go through the process of figuring out what our vertex is. And remember, the way we do that is that we calculate our x-coordinate of our vertex first, which is going to be the difference, the average between -4 and 2. So -4 plus 2 divided by 2 is going to equal 1. Then we're going to take this value, sub it in, yb. Now sub it into either this equation, factored form, or this equation. Like I said, sometimes it's always better to sub it back into the original equation. That way, if you've made a mistake in factoring, your mistake won't be multiplied. But for what we're doing, I am okay if you plug it back into factored form. Sometimes it's easier. And you should get 4, 5, 9. Not my mistake here. This should be -1, which makes this -1. This -1, which makes this -9. You know, I saw something I didn't like there. So that means my vertex, is going to be at -1 and -9. Now the last thing that we want to identify, and I have it listed here a little bit earlier as far as identifying it goes, so I'm just going to erase this, is my direction of opening. Now the direction of opening comes from the a value, and whether it's positive or negative, and this is positive, so that means this opens up. So I got my vertex, which is going to be -1, -9, so -1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 down to here. We've got our x-intercepts at -4 and 2. 1, 2, 3, 4, and 2. And then we have a y-intercept of -8, which is right there. Now, we are going to get in the habit of drawing in our, oops, that should be in front, our axis of symmetry. Let me just bring it to the front here. And that way we can just make sure that what we're doing is correct. All our points are symmetrical. And when we identify our y-intercept, this allows us to identify our symmetrical point as well. Okay, so there's our graph. And then you're going to just do the best. Oops, that was a little off, but you guys can make that adjustment. Okay, that should be your graph. It should look something like that. Okay, so that's how you graph your equation when it's not in vertex form, and in this case in standard form. So let's look at one that's in factored form. So one of the first things you're going to do is, now I have it listed here is to put it into standard form. And really the only reason that we put it into standard form is to find, so the only reason we put it into standard form is to find the y-intercept. So you're more than welcome to do distributive property here and put it into standard form, but I'm just going to show you a way of calculating the y-intercept without having to do that. And really all it is you have to remember that when you're trying to find the y-intercept, your x value is equal to 0. So if this is equal to 0 and this is equal to 0, then you're just multiplying -2 times -1 times -3. Right? So -2 times -1 times -3, which is going to give us -6. So that is our y-intercept of -6. From here, we can identify our x-intercepts, which are going to be 1 and 3. We can identify our direction of opening. This being negative means we're going to open down. Now we just have to find our vertex. So we're going to do the average. So xv is going to be 1 plus 3 divided by 2, which is equal to, so 4 divided by 2 is going to be 2. We're going to sub this value into, I'm going to sub it into this equation. So my yv is equal to -2 times 2 subtract 1, 2 subtract 3. Which should give us 2. So this is going to be 1. This is going to be -1. So 1 times -1 is going to give us -1 times -2, which is going to give us +2. So therefore our vertex is going to be at 2 and 2. Okay, so we can plot all our points. Our vertex is at 2 and 2, which is going to put us there. Our x-intercepts are going to be 1 and 3. Our y-intercept is going to be -6. 1, 2, 3, 4, 5, 6. Our axis of symmetry, I'm going to bring this to the front as well. It's going to go there. And I did forget to do something on the previous screen, but I'll go back to it. So we got 2 here, then we're going to go 2 to this side to do our symmetrical point. And then we're going to draw our line. And this should be a curve. I do not have a curve here. Should be a curve at that point. Now we have to, this is what I did not do on the previous screen, is we need to label our axis of symmetry. So in this case it's 2, and on the previous screen it was going to be x is equal to -1. Okay, so you need to label that as well. All right. Now we're going to move into a little bit of a word problem and just kind of put these things into a practical aspect or a practical application. Right? It's not graphing or dealing with quadratics is not all about just dealing with the equations. It's also understanding word problems that are involved. So first thing I'm going to get you guys to do is I want you to read this question and completely understand it. And remember, if you don't understand it, read it again. And if you don't understand it, read it again. And then if you don't understand it after 3 times, get up, walk away, take a break and come back, or ask somebody, one or the other. Sometimes some fresh eyes will help. Okay, so take a second and do that. Right now, a lot of times dealing with a question like this, I would always suggest that you draw a little sketch of what you think the situation is going to look like. I can draw something a little bit better here. All right, so here's my cliff. Okay, here's the ground below. Here's my little person up here. Well, I'm just going to draw the ball, I guess. Here's my ball, because we're just assuming the ball is coming from the ground, not from the person's height. And when you toss the ball, they're tossing it. The ball is thrown vertically up from the top of the cliff and then falls to the ground. So I'm going to say that the graph goes like this. It's going to go vertically up like that, because that's generally how you throw a ball, and then it's going to come back down to like that. Now, the first question is asking you, how tall is the cliff? So we're assuming that the ball is right at ground level. So we would need to figure out this height right here. Well, this here, this height, is the initial height of the ball. And you've heard that terminology before. This is our initial height, or our starting point. Well, this here is our initial height, or our starting point. What we can do is we can think of this as an axis. There's our axis. So this is our y-intercept. This is our starting point, our initial point of the throw. Which means that our how tall is the cliff is going to be 60. And then you have to reference the question to figure out how height is measured. In this case, it's measured in meters. Meters. Now, when does the ball hit the ground? Now, I want to look at this shape that we've drawn here, and essentially what this kind of looks like is a parabola. So we could kind of extend the graph down this way. And the points at which this hit the ground are right here and here. Now, we're not going to have values going back this way, and I'll explain that why later. But here is where we're going to have a point that hits the ground. And what is this? Well, I've created my axes right here. So if my graph is coming up and comes down and hits the axes right here, this is going to be my x-intercept. So in order, when does the ball hit the ground? I need to find my x-intercepts. The height is going to be 0, which means I need to find my x-intercepts. So I'm going to take my equation. So part B. So h, I'm going to factor out the -5. And I'm left with t squared, subtract 4t, subtract 12. I'm going to keep factoring from there, so -5. Two numbers that multiply to get -12 and add to get -4 are going to be -6 and t +2. Which means my x-intercepts, in this case t, so from this one, t is going to be equal to 6, and t is going to be equal to -2. Now, I said here that this one here is not possible in the sense that we're never going to go backwards like this. And just by looking at this equation, we've got two variables, h and t, where h is height and t is time. So if this is my height here, then this is my time. And if this here is the 0 point, that means this would be -2. Well, you can't have a negative time. So This value here is inadmissible. It's not possible. Okay, so what we're going to do is we're going to write inadmissible. Okay, because you can't have a negative time, but you can have a positive 6. So when does the ball hit the ground? Well, it hits the ground at 6, and time is measured in seconds, which is right here, in seconds. Now, how high above, oh, sorry, I'm a C. When does the ball reach its maximum height? Well, there's two different ways of doing this. Okay. We could try and figure out what our vertex is, or you could graph it. Now, I'm going to go through the process, and I'm going to find the vertex. Okay, so C. So to find the vertex, I need my x-intercepts. So I'm going to find my t vertex. So my time vertex is going to be equal to 6 plus -2, all divided by 2, which is going to give me 2. Now, when does the ball reach its maximum height? Well, the statement of when is time. So the maximum height is going to be reached at the vertex, and I've already found that my time is 2 seconds at the vertex. So this is going to be 2 seconds. Now, how high above the cliff is the maximum height? Well, the maximum height is here, so I need to find that. So I'm going to go through the process, and I'm going to find the maximum height. So that's going to be D. And to find the maximum height at the vertex, I need to sub in my time at the vertex. So if I sub that into my equation, now I'm going to sub it into here, my factored form, because I find it a little bit easier. So my height at my vertex is going to be -5 times 2 subtract 6, 2 plus 2. And then you're going to be equal to, let me see, 80. So that is my height of my cliff. But I want to know what it is here. How high above the cliff is this? So in order to do that, oops, I'm going to have to go, and I'll say height above is going to be 80 subtract 60, because that's my initial height, which is going to give me 20. So this is going to be 20 meters. Now for question E, we will eventually learn a skill in order to do this one. Okay, but for right now, I'm going to suggest that what we do is we graph it. And we have all the information now to do it. We've got our x-intercepts, we've got our vertex, and we know what our y-intercept is. So we can graph this quite easily. So to save a little bit of time, I'm just going to show you my graph, which is this. Let me get it in here, right there. Now for part E, it's asking when the ball is on its way down, when it is at the same height as that is thrown. So here is its initial height, so it's thrown upwards. This is on its way down. So I want to know what this time is. So therefore, that's going to be at 4 seconds. So part E, and I guess I'll just write it here, is going to be at 4 seconds. And then how high was the ball at 3.5 seconds? Well, that's just a matter of looking at the graph. You could look at the graph and come up with a value. I'm going to plug it into the equation. So at 3.5 seconds, F, so T is equal to 3.5. I'm going to sub it into this equation. So height is going to be -5 3.5, subtract 6, 3.5 plus 2. And let me see, this should give you a height of 68.75 meters. Okay. And then you can just write the answer in right here. All right, so bit of a long process as far as working through this problem, but it's really not that challenging in the sense that it's everything that we've done. You just have to identify your vertexes, your vertex, your x-intercepts, excuse me, and then you're just plugging numbers into the equation. Okay, so it's just combining everything that we've done to this point. So this is what I'd like you guys to do for homework. Now, I want you to graph these 6 questions using the vertex and your x-intercepts and y-intercepts. And then to check your answers, just plug these equations into Desmos and see if you get the same answer.